Hello, and welcome to this talk about growing the PHP core one test at a time. My name is Florian, and if you want to scream at people online, you can find me on Twitter at @RealFlowControl. I'm a PHP developer, and I'm working remotely for a company called Oxidity Sales. I'm contributing to open source, and the libraries that I contribute to is mainly stuff that I use in my professional work. That's, for example, GraphQLite, PHP Unit, and also the PHP core. And I'm doing so although I'm married with 5 kids. So if you do not have at least 5 kids at home, you'll probably be able to find some time to contribute to open source. So why are we here today? I personally got introduced to PHP in September 2000. That's more than 20 years ago from today. And my entire professional career is based on PHP, with a few exceptions in exchange for money. But I would say that 90% of the time I get paid to solve problems, and I do so by using PHP. So that means that everything that I have in my entire career is based on the fact that PHP exists, that people built PHP back then, and that still today there is a community building PHP and adding new stuff. And it's about time to give something back to the community. And in 2017, I stumbled on the PHP test fest. I have to admit that I do not remember exactly how I found out that this is a thing at all. And the 2017 edition was the last edition so far, but Ben Ramsey and Sammy Powers did a good job in running this one. And the main idea of the test fest is to write tests for PHP. And when I browsed to this webpage and wanted to find out how this is actually done, I've seen that you write tests for PHP in PHP. And this was a thing where I immediately know you can do this. I mean, you're a PHP developer after all, so you can write PHP code. And you don't need to create a new language or C. You don't need to create patches in C code. You don't need to do this. You just need to write PHP code in order to write tests for PHP. So I immediately knew this is a way to give something back to the community. So I started writing tests, and I want to show you how you can also write tests and what you need to do, how to get your machine prepared and everything. So let's start with compiling PHP from source. If we want to run the tests, we need the source code from PHP. So you can find the PHP source code on GitHub. Most likely it's a good idea if you create a fork from this repository, because I think that nobody here in the audience, including me, has write access to this repository. If you have compiled stuff on Linux before, then there's nothing surprising you. You just run build conf, then configure, then make, and then you have your binary. And I would say, let's do so. As stated on the slides, we run build conf. Build conf creates the configure script or prepares the configure script. And then we run the configure script. In this case, we need it with setlib for an example that we're going through later. Configure checks if everything that it needs to compile PHP is on your system. It might complain that, for example, in my case, it complained, for example, that there is libxml is missing. Reality is libxml was installed. What actually was missing was the libxml header files. So you need to install the development packages. On Fedora, they are suffixed with -devel. On Debian, for example, or Ubuntu, it might be -dev. When we compile when we run configure, we can finally compile it. In my case, I prepared this already because compiling PHP will take some time. So the make script will not do much, but just link all the object files together. And after we have that, we can actually execute the PHP binary that we just compiled from the source code ourselves. And you can see that we have PHP 8.1 running. And you also can see when I prepared this talk. So now we have the PHP binary. Let's go back to the presentation slides. Next thing is we have the binary, so we can run the tests. Nothing too fancy here. So let's just copy paste this one into the terminal. No, it's not a good idea to copy paste things from the internet, but this is a local slide. So when we run the tests, this PHP 7.4, the test runner is able to execute tests in parallel. So it's much faster than before. And what you see a lot on the left side is a lot of pass. You will see some skip. One warning, if I remember correctly, no failures, and some expected failures, but that's okay. There are some tests that cannot run in parallel. You will see a decrease in number of concurrent test workers soon, and when the concurrent test worker is down to 1, then all the tests that cannot be executed in parallel will be executed. So also you see here that PHP is not good at counting. We do not want to send the test result. After the test is through, the test runner asks you if you want to send the test result to the QA reports list. We don't want to do this for now. So let's scroll a bit up, and here we see the test result summary, and we see that 45 extensions have been skipped and 27 extensions have been tested. That means that only 27, probably only 26, because we had to add the setlib, are bundled by default, and 45 other extensions are just not bundled by default. We skip those tests. Overall, there are 16,000 tests in the PHP core. 11,000 got executed today, and we have 4,800 tests skipped. This is the skip tests from these 45 extensions. We have 1 warning, 30 expected failures, and overall 99.7% of tests passed. And the greatest thing is that all those tests passed in 46 seconds. This is really nice. You have also an expected fail test summary. So there are tests that are expected to fail. The reason is mostly upstream bugs or things like stuff that you solve in upstream, and you know that when we can finally merge this stuff from upstream, or when we can merge another pull request, then this bug will be solved, but up until now it is expected to fail. Okay. In most cases, you will find a link to a discussion where people are discussing about this particular case. And then we have 1 warning. This 1 warning is this specific test. It is a warning because it was expected to fail, but actually it didn't fail. It passed, which it shouldn't. So this is a warning. Okay, let's go back to the slides. How does a test look actually? Now we executed those tests, but how do they look? This is how a test case look. These are PHP files, and these are basically PHP files with sections in them. The first section that you'll find in every PHP file is a test section. In this case, you have thus just the word string length function. So what you do here is you write down what are you actually testing, what's the PHP function you're testing, what are the circumstances you're testing. It should be pretty short because it's printed out by the test runner when the test is being executed. If you have more text, more description, there is actually a description section that you can use for this. Then there is the skip if section. As I already mentioned, not every extension is bundled with PHP by default. Even when we compile the from source, we have to, for example, in our case, define that we want the setlib extension. If I wouldn't have done this, setlib wouldn't have been compiled. So it might be that the extension is not here, or there are other circumstances that mean that it's not a good idea to execute a test, or that you actually know this test will fail anyway. It doesn't matter. So there is a skip if section, and it actually works like this. The PHP test runner will execute the source code in this skip if section, and if the output starts with the string skip, it will skip the test. Then we have the file section. The file section is your actual test case. Here is what you actually want to test. In our case, we want to test that the string length function returns the correct integer length for the string hello world. So what we do here is we just var dump out the return of the string length function and then match this against the contents of the expect section. The contents of the expect section have to match completely to pass. There are cases where you have dynamic output. Like you have a stack trace, for example, with file system path. In this case, you can use as an alternative to the expect section, the expect f section. That means that you are now allowed to use substitution tags that you know from printf. For example, you could write, in this case, not expect int 12, but expect f int %d, which means just a decimal. This would also match. It would render the test useless, but it would match. Then you have the clean section. The clean section is just to clean up after yourself. So for example, you create some temporary files in the file section and you want to clean up somewhere and you want to make sure that the cleanup is called. It might be that, for example, the PHP process sec falls in the file section or it exits early. Then you would not clean it after yourself. So there is a clean section that cleans up after yourself. But there's one thing you need to keep in mind. All those three sections that we had here, the skip if, the file, and the clean section, all of those sections are executed in isolation. So the test runner will only execute that single piece of code in a new child process. And then the next one, then the next one. This means that you do not have access to variables from one of the other sections. Okay, so for example, what you could not do here is that in a file section, you have a variable with a file name that you create, and in the clean section, you just use that variable again to clean this file up. This is not possible because you do not have access to those other things, okay? Now that we know how a test looks, now we can run them. What do we test actually? Back then when I started writing tests, you could go to cheatcraft.php.net, but cheatcraft.php.net is retired since PHP 7.4. Because cheatcraft is not able to build PHP 7.4, it's also not able to build PHP 8, so you will not find a up-to-date code coverage report there. But you can head over to the Azure pipelines for the PHP project, find the latest schedule build, and select the code coverage section. And there you have a code coverage report that's up to date. So when I went to cheatcraft.php.net, back then this was possible, I found this. I found something rat. So in the setup extension, that's why I compiled it. I found this setlib coding type function, and I've seen that the setlib coding type function is not covered at all. There is no coverage for this, and it looked awesome simple. It looked like a low-hanging fruit. I mean, basically, if you look the source code, this is C source code, but as a PHP developer, you're able to understand what's going on here. Basically, it's a switch on a compression coding variable. And depending on the content of the compression coding variable, it returns a string gzip or a string deflate, or it returns false. That's what it does. And so I searched a bit in the source code how this function actually is behaving. Like, what's the bigger context? I mean, it's like, technically speaking, how can I influence this compression coding variable? I wanted to understand the bigger context. So I also checked out the documentation at php.net. So you just head over to php.net/setlib coding type, and you can find out everything. So what actually happens here, the bigger picture on all the setlib coding type function, is the following. An HTTP client might send an accept encoding header with the string gzip to your PHP process. PHP has the functionality to magically output compress the response body in whatever accept encoding the client sent. Not whatever, only gzip and deflate are supported at this point in time, but if the accept encoding sent with the HTTP request is gzip or deflate, then PHP can automatically compress the response body in gzip or deflate, whatever that was. And the next thing is, so we know that like PHP, the setlib extension, and this setlib coding type method then is reacting on this accept encoding HTTP header. And also, you as the operator of the server have the possibility to influence if PHP should do this at all or not. So there is the setlib output compression ini setting, and you can set this to on and off. If it's off, then setlib coding type will always return false because it's not doing it. It's not doing anything. If the setlib output compression is set to on, then the response of the setlib coding type will behave on the accept encoding header. If the accept encoding header is not set, or if the accept encoding header is something that's not gzip, not deflate, and we do not know whatever that is, the setlib coding type will return false, because the actual state is that PHP, also it is allowed to do output compression, cannot do output compression. So it's not doing it, so it's just returning as false. But if the accept encoding header is being set to gzip, the setlib coding type will return gzip. If the accept encoding is set to deflate, then the setlib coding type will return deflate. So now we have the context and the bigger picture and everything just from consulting the documentation. I would say write a test. And I prepared some tests for us. In this case, I prepared the case for the gzip. So what we have here, we have a basic test case. We've already seen that. We have the test name. The test name is setlib coding type with gzip encoding. That's what we want to test. We already learned that the setlib extension is not bundled by default. So we need to guard this in a skip if section and check if the setlib extension is actually loaded. If it's not loaded, then we can just skip the test. So as PHP developer, we know that we can influence the HTTP request headers using the $_server autoglobal. So we can just write to $_server HTTP accept encoding and we write the string gzip to there. Then the next thing is we set the setlib output compression off. And when we have this, then we call setlib decoding type. And in this setup, with having accept encoding set to gzip and the output compression set to off, setlib decoding type should return false. This is what we have in the expect section. The next thing is we set setlib output compression to on, and after that we have accept encoding gzip, output compression on. This should return gzip. So we do another call to setlib encoding type, just var dump out the return value, and this should be a string of gzip. So let's execute this test. We can execute a single test by adding the test argument, and then you can give it either a path to a directory. Then the test runner will execute all the tests in this directory, or you can give it the explicit file name. They will only execute this one test. And now, wish me luck. And it failed. So the test summary is just we have this failed setlib decoding type with gzip encoding. That's our test definition. That's the file. So I actually executed the correct file. We have one test executed, and this one test failed. So we have a failure rate of 100%. That's not nice, but the good thing is it failed pretty fast. So now we need to know what happened. I mean, we know it failed, but we are interested in actually why did it fail. The test runner, we have all these single sections. We have the test section, the skip, the file section, and so on. What the test runner does, it will split these sections into several files. And also it will create a log file for us. And this file will be called the same as the PHP file, but not with the PHP ending, but with the log ending. We can look into this log ending and see what happens. So we have the expected output and we have the actual output. And the first one actually matches, but after that we have a warning. And this warning states that you cannot change the setlib output compression because headers are already sent. And we know that. We know that from session start. We do session start somewhere and it cannot start the session because the headers have already been sent. And yeah, actually, when we look at our test, what we do here is in line 9, we var dump the return value of setlib decoding type. When we do this, this actually means that PHP will send out the response body. But before sending the response body, PHP will magically send the response header. And the response header being sent out, in this case, probably they state that there is no encoding done in the file. But that means that we cannot change this anymore because there's no way for us, for PHP in this case, there's no way to somehow tell the client that although we told you a few bytes before in the response header that we will not do output compression, we decided to, well, just do it. This is not possible anymore, so we cannot change the setlib output compression setting. So yeah, but we know how to solve this, and I prepared the solution to this problem. It's fairly easy. What we do is we just do not var dump in line 9, okay? We just store the value of setlib decoding type in a variable and do the same thing in the next line, line 11. This is a bit expressive, to be honest with you, but you get the point, you see it better what's happening. So we have the off and the on. This in off should be the boolean false and in on should be a string gzip. So now at least the warning should be gone and we should see our string gzip finally. So let's execute this to the PHP. And you can use the same trick here, just make test setlib to.php and execute this, and it failed. Still it failed fast, but we also know what we can do. We can just have a look at the log file. What we see is, oh, it's not working. We see the expected output is false and gzip, but the actual output is false and false, and there's like no warnings anymore. So there's no warnings anymore. Let's have a look. What's going on? Well, we have $_server HTTP accept encoding set to gzip, and accept encoding is correctly spelled, gzip is correctly spelled, it's actually an assign, it's set to off, there is no header being sent, we can actually, like any set, the setlib output compression, we can turn it on, so it's on, it's gzip. This should behave, but it's not behaving as expected. So what can we do now? What can we do now? In this case, one thing we can do, we can consult the source code and dive deeper and search for everything, and you'll probably find something. In the end, I searched a lot, but I could not. It just didn't make sense. I found the place in source code where the assign to that variable is done, but it didn't make sense. I could not find out. So what I did then was I went to phpc.chat. And phpc.chat, there is a lot of nice fellows from the PHP community, a lot of core contributors hanging around. And I asked them the question, why is PHP not behaving, in this case, as I expected to behave? And something's wrong, missing, Borkus, I don't know, something is crazy. And I learned something that day. One thing that we already know as a PHP developer is PHP is copy on write. That means even though you do not explicitly call by reference, PHP will, if you're in user space, if you call a function, it will just give a reference to the variable that you pass to that function. And as long as you do not write to this variable, you will work on the original, just with the reference. But as soon as you write to this variable, PHP will automatically create a copy for you to work on. So, and the same is true for all those superglobals. Those superglobals are copy and write. That means that I can write to $_server HTTP accept encoding. I can write to that. But what happens in this point in time is that PHP will create a copy for user space to work on. And PHP itself will still work on the unaltered original. So effectively, this makes all these superglobals, the $_server environment, post, put, get, whatever you have, it makes all of these variables immutable to the user space. So in user space, you can change them and user space will react accordingly, but not the PHP core. So there's one thing I learned. And the next thing I learned is there are modify handlers for any settings. I also asked the question, where does PHP actually know that I cannot do this ini set call anymore that I've done in the first iteration of the test when I did the second call to ini set, and they stated that like every call to ini set is not just setting a variable. Actually, what happens is there is a function being called. This function checks if you are able to change the setting at this point in time. If you're not able to change this setting, it will issue a warning, and ini set will return false, which is an interesting thing where I came to like, wow, it's like I always just call, if I have to, I just call ini set and fire and forget. But yeah, actually, I should check on the return value. So this looks like a sad ending for the test. We do not have, like from user space, from our file section, we do not have any way to alter this accept encoding. But there is one more thing. There is one more section that comes in handy now. What you can do in the test runner is you have an environment section. So what we can do is we can inject this HTTP accept encoding variable as an environment variable from the outside. So the test runner will set this as an environment variable before calling the actual source code that I have in the file section. And if we do this, and if we read then in the file section from the $_server HTTP accept encoding, we also find the string gzip there, but also PHP in core has the same string. It has this value and it has the string with the value gzip. So this should do this, right? Let's go through this. Setup encoding type with gzip extension. Extension is not loaded, then skip. Yeah, it is loaded. We set the environment. We set it to off. We call it. It should be in off. We set it to on. We call it again. It should be in on. So var_dump off should be false, and var_dump on should be gzip. So this time it should work. So let's hope for the best. And it failed again. It failed fast, but it still failed. but we know what to do. We can consult the log file, and let's have a look what we have here. Wow, this output does really not match the expected output. So this is completely bonkers and has nothing to do. And I think that like in the earlier edition, we were closer to what we thought. But wow, let's think about it again. We told PHP that the client accepts gzip encoding, and in the end, the output compression is turned on. That means that PHP is allowed to do gzip encoding. So this actually is a setlib, a gzip compressed output stream. So what we need to do is we need to disable output compression again before doing any output. And so preventing that PHP will actually do output compression. It should not output compression in this case. So what we do is I added this line 13 here, the setlib output compression off, then do the while dump off and on, and now it should not magically do output compression anymore because we just turned it off. Let's see if it works this time. For.php, and it passed. So we have our green passed, setlib output compression with gzip encoding, just on one test, so we have 100%, that's nice, and it still is fast. So, awesome. Now, just for a recap, this is the final test case that we have. We have our test name, we skip if the setlib extension is not here, we need to set the environment variable to inject it from the outside into the PHP process that executes our file section. And yes, this is a bit expressive, the file section, you can do this way better. You have also, there is a ini section where you can deliver initial ini settings, then you would not have to do so much stuff in the file, but you can clean that up later. In the end, we have green test, and now we can refactor it to be better. So I made a pull request with the HTTP accept encoding to gzip, to deflate, to something else, and with no HTTP accept encoding at all. And this has been merged into PHP 7.3, and in GCAF, PHP 7.3 still was on GCAF. You could find this. So actually, I covered the lines that I wanted to cover, and I covered a lot more lines, but I wanted to cover this setlib encoding type and actually made coverage for this one. So what have we learned? What looks simple might be complex. Obviously, the usual thing. I thought it's a low-hanging fruit. It was a lot of work. I learned a lot the way. But it was worth it. The next thing, superglobals are copy and write. I would have not thought about this. I knew that PHP works copy and write, but not with superglobals. And this is true for all those ones. This is true for $get, $server, put, post, whatever you have. It's not for $globals. $globals is something very special thingy, but all the rest, okay, all the rest. And therefore, this that you have superglobals are copy and write, this makes everything immutable to user space that you get from the outside. And it actually makes sense. When the client sends me an HTTP accept encoding header with the value gzip, it makes no sense for me to change this. And it should not, because like when they tell me they are accepting gzip encoding, and we change this to deflate for whatever reason and send them a deflate compressed body, they have no chance to decode this, because they actually told us they'll not be able to understand, so it makes no sense. And then there are modifier handlers for ini settings. This is a nice and interesting thing. I already mentioned that. I should personally learn from this that I should, when I have to call ini set, I should check on the return value, because it might not be able to change the value. Okay. So now that you know all of this, the question is, what do you personally gain? Like when you will start making PHP files now and create a pull request for PHP, what do you have from this? Okay, so one thing is the usual thing when you write tests, those things, in this case PHP, will be more stable and reliable. It will not out of a sudden change behavior with the next release. This will not happen anymore because you have a test, and the test nails down how this specific method should behave. The next thing is you gain a deeper understanding of how PHP works internally. We learned this copy and write stuff. We learned that there are any handlers. I personally learned by searching for something else to write a test for that there is a zip archive class. In my case, I was pretty lucky because 12 years ago was the last time I had to work with zip archives in PHP, and there was no zip archive class. So what did I do? I created a simple class that wrapped the unzip and zip binaries on the CLI, which is a horrible thing to do. Do not do this. And by searching for something to test, I found that there is a zip archive class, and I was like, wow, you should have this sooner, but well, here it is, and write some tests through it. And lucky me, 3 weeks later, I had a new user story on the board with someone's going to upload a zip archive somewhere, and we need a PHP script to just open this file, extract something from this, and do something with it. And I was like, I know how I can do this. No wrapping of binaries anymore. Fine. And the next thing is, what you also gain is the PHP test format. It sounds like something very specific to PHP only or to the PHP core only, but the PHP unit has a test runner to execute PHP files. And actually, a lot of the tests for PHP unit are written in PHP file format. So this is actually how I became a PHP unit contributor. I just went to a PHP unit code sprint and started writing tests, PHP tests for stuff in PHP unit itself. So this is what brought me into PHP, being a PHP unit contributor. And there is one last thing that you personally gain when you start writing tests for PHP, and you can tell this anyone if they want to know or not. You can tell that you are a PHP core contributor. Thank you very much. That's all I have for today. And if you are interested in more on this topic, you can head over to the phptestfest.org domain. This is from the 2017 edition, and you'll find a lot of YouTube videos telling you how to write tests, what to test, how to set up your test environment. Then you can also go to qa.php.net. This is the quality assurance page. You will find there, for example, the whole definition of the PHP file format. There is more sections than we had today. And you can go over to dotbox.org, which is my domain and my blog. And there you find the slides to this talk. And there you will also find a blog post with the same topic, growing the PHP core one test at a time. And this one also describes how you can create your own local code coverage report. Thank you very much.